Good morning, all. For those of you that just joined, we're holding on here just to ensure we get the maximum number of participants and we queue up the IPA, ICC, and E3 teams on our end. Give us one more minute and we'll begin. Thanks. Good morning. Welcome to the ICC, IPA, and well, right now it'll be co-hosted by the E3 team on the mitigation plan and the IRP workshop. This is the April 7th workshop, not to be confused with this Friday's April 10th workshop. We're going to get started. A few initial things. Charlotte, if you'll move to the next slide. There's disclaimer and kind of some high level things. So first and foremost, as you should have been alerted when you came into this workshop is being recorded. It's automatically recorded. We'll give announcements at the very end about next steps and where to find certain things. So hold on for that. We're going to try to get into the material as quickly as possible here. So for the purposes of the disclaimer, these slides and their contents are intended for informational and discussion purposes only and do not represent a legal interpretation or statement of policy by the ICC, IPA, or its staff. And the contents presented, views, and opinions expressed during the webinar do not represent a legal interpretation, nor do they represent statements of policy or statements of fact by any of the parties, ICC, IPA, or others. And the goal of these webinars is to purposefully inform and elicit participation from a variety of stakeholders, all of you, as we work through this process. So with this, I'm going to hand it off to members of the E3 team to walk through. Please note as we go throughout, one other item I'd very much like you to do is if you could go into your name profile here and update just what company or agency or entity you represent, just so we have kind of a feel as we go throughout this. And as you ask questions, it'll enable us to see kind of on behalf of whom you're asking the question. So with that, I'll hand it to Rochelle. Thanks.
Perfect. Thanks, Jim. Hi, everyone. Rochelle Sampson with Veritas Consulting. As Jim was saying, we do ask that you change your name if you haven't already to include your organization at the very end of your name. And if you would also like to, we would like you to introduce yourself in the chat, including your name and organization as well. We also want to make sure that this is an active participation. So we will go ahead and go through our materials. And then at the very end, time will be set aside for you to ask any questions as well as make any comments or feedback and everything throughout or at the end of the session. But if you do have questions on a specific slide, we do ask that you notate whatever slide that you have questions on, and then you can reference that during the Q&A session at the very end. And so once we get to that Q&A session, we just ask that you, if you want to ask your question live, we just ask that you use the raise hand feature to ask your question, provide any comments or feedback from there. And then you will unmute you can just go ahead and unmute yourself when a moderator calls on you, and then share your name and organization that you're calling from. And then again, you can also use that chat feature, which will also be moderated. And so just some last minute housekeeping things, just want to make sure that we are respectful of other people's perspectives, as well as making sure that we allow time for participation for all of our participants. So just make sure that you're concise in your questions, comments, or feedback from there. And then we will also be soliciting some post-meeting feedback by way of a workshop comment form. The link was provided in the materials as well as a QR code, which we will also share towards the end of the session. And then, as Jim was saying, this meeting is being recorded, so it will be posted to that ICC IRP website. And then next slide. And then we'll run through a quick overview of the agenda before we get started. So we'll start with the objectives of the Illinois IRP and mitigation plan. And then we'll go through the stakeholder responses that were provided on the IRP and mitigation plan, our proposed approach to scenario design, and then the proposed scenarios for IRP and the mitigation plan. and we'll talk through next steps. And then at the very end, we will have the stakeholder Q&A and discussion at the very end. So that'll be the lay of the land for today. And I'll pass it on to Charlotte.
Thanks, Rochelle. Hi, everybody. My name is Charlotte Fagan. I'm an associate director at E3, and I am the project manager for the IRP and mitigation plan. Today, I'm going to be talking through the objectives of the IRP and mitigation plan, summarize a little bit of the stakeholder feedback that we have received and heard so far, and how that has informed the scenarios that we are going to put forth today. I will also speak to kind of how we approached scenario design before I hand it to my colleague, Nate, who will talk through our proposed scenarios. So I think it's important to first situate that the mitigation plan and IRP are one component of a wider ecosystem of Illinois planning studies. And what we see here on this visual on the right is we see these planning studies across the ecosystem, that they all work from a common set of inputs to inform those studies and plans. Those studies and plans inform the actions that the Illinois agencies take, and in turn, those actions, again, sort of like update the inputs, and that cycle repeats throughout the sort of various iterations of these plans and studies. And the idea behind this is by working with a coordinated and consistent set of inputs that we can arrive at a coordinated set of actions coming out of these various studies. In the stakeholder comments that we have received so far, there was broad consensus that we should coordinate the mitigation plan and the integrated resource plan to reduce redundant processes. We know that there is a lot happening in Illinois right now and a lot of stakeholder forums, and we appreciate you all taking the time to be here today. And we hope that by consolidating some of that input and assumption, feedback, and stakeholdering, that we are helping to sort of consolidate all of our calendars here. Lastly, that this year the mitigation plan will form part of the integrated resource plan. It will be it has its own standalone analysis that is specific to the mitigation plan, but it will be kind of presented as part, these two are sort of part of one whole. As laid out in the legislation that was passed earlier this year, the IRP must address 6 key areas. The overall goal here is to maintain a reliable, affordable, and clean electric system over time, and the IRP is meant to provide sort of a strategic roadmap to Illinois for that. The first piece is the load and system outlook. Legislation requires that we examine at least 3 load forecasts and that we consider the impacts of electrification, economic growth, and large new loads in those load forecasts. We're also supposed to look at expected resource retirements and additions and how that might impact the system outlook. Next, the plan must consider resource adequacy and reliability and ensure that Illinois has sufficient resources to be able to maintain a reliable system. It's supposed to evaluate potential capacity shortfalls and system constraints relative to system changes over time. And so ensuring a reliable and resilient system is part of the analysis. Next, the IRP must also consider the evaluation of resource options. And so here we're looking at the roles of clean energy resources, storage, demand response, and transmission to help meet those needs, and what the different sort of portfolios of resources we might consider across the IRP, and how those resources might change over time as future needs evolve. Fourth, and this is of course the subject of today's workshop, is scenario analysis. Legislation requires that we evaluate multiple scenarios, looking at different assumptions around demand, technology development, and resource availability. And of course, today is the place where we are laying out some proposals around scenario development, and we will be asking for your feedback about those scenarios and how we might evolve them towards, as we continue on with the IRP. Fifth, the IRP must consider cost and consumer impacts. We need to assess the total system costs and customer cost impacts of the different resource portfolios studied across the IRP. And we must evaluate the trade-offs between cost, reliability, and environmental outcomes, while also factoring in the equity impacts and opportunities. This includes considering kind of environmental justice and how that is, how equity impacts are impacted throughout the different portfolios that we're considering. And lastly, also looking at environmental and policy outcomes. We must evaluate the emissions impacts and environmental outcomes of the different portfolios we consider, and identify strategies that support Illinois' clean energy and reliability goals. So although we are looking at these as sort of interrelated processes between the mitigation plan and the integrated resource plan, these two do have sort of distinct objectives for the two studies. First, the mitigation plan is really focused on addressing reliability risks that were identified in the resource adequacy study. If you have not read the resource adequacy study, strongly recommend revisiting that document, as that is really the foundation for the mitigation plan and sort of what triggers the mitigation plan taking place this year. The mitigation plan is focused on maintaining reliable electric service, identifying practical solutions and actions that can reduce or resolve the identified shortfalls under different scenarios. And as we consider different actions that the state might take, we must prioritize low emission solutions and also think about limited flexibility in emissions timelines if necessary to maintain reliability. And I would say this last bullet point is common to both the mitigation plan and the IRP, that we need to provide a transparent process for agencies and stakeholders to review the potential reliability solutions that we are considering. Now, that mitigation plan is really focused on those reliability risks and focused on the shorter term, focused on the next 10 years, let's say. Whereas the integrated resource plan, this is I like to think of it as sort of a strategic roadmap. This is longer term and wider in view than the mitigation plan, is really considering at a higher level, how will Illinois meet and develop a strategy for a reliable, affordable, and clean electric system in Illinois over the next 20 years. It will assess long-term capacity requirements and system constraints to ensure reliable service. It will evaluate and think about different pathways for meeting those needs. It will analyze system costs, reliability, and environmental impacts under different scenarios, and provide strategic guidance to the state for future planning and investment decisions. And the focus here is really on, from today through 2047. And so 20-year horizon, and really thinking about that overall big picture. How is Illinois going to achieve its both policy goals while maintaining a safe and reliable system? Now, just as important as what the objective of those plans is, it's also important to think about what is outside of the scope of the IRP and mitigation plan. And we really think about three main areas that are outside the scope of the study. First, changes to regional capacity markets and RTO rules, approval of specific projects, and changes in Illinois policy. So in that first bucket there, the mitigation and IRP do not change PJM or MISO, their operations, their market rules, their capacity constructs, but it can inform RTO planning, and it can certainly inform IPA and ICC advocacy actions at the RTOs. But the IRP itself will not change those regional capacity markets or RTO rules, as that is administered and regulated by PJM, MISO, and approved by FERC. Second, the IRP and mitigation plan will not consider approval of specific projects, right? We are looking at how the system is going to evolve and necessary resource portfolios to meet those needs, not specific projects. And so decisions about specific projects will occur through separate regulatory, permitting, and procurement procedures. And lastly, there's limited authority here in terms of changes in Illinois policy. The mitigation plan and IRP operate primarily within existing Illinois law. And so SRJA does allow to consider and test different policy changes to inform planning decisions, but the plan itself largely operates within the existing policies. In the proceeding that will be initiated once the IRP is submitted, the Commission may modify or consider certain policy changes that is within their statutory authority. But the IRP itself is largely considering policy as it exists today. Here we have the many different data requirements and inputs that go into an IRP. You can see on the left there about 10 different categories of inputs. That third category, candidate resources, will be the topic of our Friday workshop when we reconvene. The point here that we want to make is that the IRP draws from a lot of different data resources, and we really try as much as possible to rely on public data sources. Because this is a public process, we want to be as transparent as possible, and so being able to point to public data sources helps to provide that transparency to all stakeholders in the process. And so the last slide of this section is just to give you all a sense of what we are anticipating across this spring and summer in terms of the next stakeholder workshops for the IRP and mitigation plan. So of course, today we are in workshop 1 around scenario design. We will see you all again on Friday for the candidate resource workshop. And that will sort of round out our workshops for April. In May, we will meet again where we will propose our customer cost impact methodology. So we will bring forth sort of our framework and proposed approach to how we will calculate customer costs and the impact of different resource portfolios on total system costs. And we will be seeking your feedback. And then in June, we will have a 4th stakeholder workshop where we walk through our ELCC results. ELCC here is referring to the reliability contribution of different resources to the portfolios. Then in late summer, we will have our last public workshop, which will be walking through draft results. And then in November, the IRP and mitigation plans will be submitted to the ICC and proceedings will be initiated for each, for the IRP and for the mitigation plan. So we know that there are a lot of stakeholder workshops happening across Illinois right now. I really appreciate you all taking the time to be here today and hope that you will all stay involved in the many stakeholder workshops to come the rest of the spring and early summer. Okay, so the next section here is we're going to talk through the feedback and sort of responses that we have already heard in terms of scenario design for the IRP and mitigation plan. So these were comments that were submitted to the IPA and ICC in January and February following the workshop then. So we received, our IPA and ICC received responses from 22 different stakeholders. As you can see in that pie chart on the right, it was a good representation across clean energy and policy advocates, utilities, energy developers and power producers, and consumer and industry representatives. A pretty good representation across those 4 categories of stakeholders. Of course, want to encourage folks to continue to stay involved, and the wider swath that we can represent here, the better, of really making sure that we're bringing all voices to the table. So in those questions that were posted and in stakeholder responses, we asked stakeholders around what were the most important drivers of scenarios that we should consider. And pretty consistently across stakeholder responses, we saw, looking at CEJA compliance and then also looking at an extension of CEJA plant retirement deadlines as some of the most important scenario drivers to consider in the IRP. Stakeholders also commented that looking at whether or not new gas plants are allowed, looking at different demand growth scenarios, as well as reduction in time to interconnect and aggressive decarbonization goals as additional drivers of scenarios that we should consider. In one of the stakeholder responses, it also asked stakeholders to rate 6 different criteria in terms of how important they were in being included in scenario drivers. And what we saw here was the most common response of ranking a 5, which was the most important, was looking at CEJA retirements and looking at whether or not new gas was allowed in Illinois. And then third most common rating was looking at the storage portfolio budget versus an expanded storage portfolio budget. I think it's also important to note here that a lot of respondents also noted interconnection timing as one of their top 3 choices. As being important, and that generally the renewables budget and energy efficiency budget was not ranked as highly amongst all stakeholders. And then lastly, in those stakeholder comments, it also asked stakeholders for feedback around looking at the load forecasts and what should we consider on the demand side and demand sensitivity when looking at different scenarios. Of course, many stakeholders commented on the need to look at large load and data centers in different load forecasts and consider their impact on the system. Stakeholders also commented quite a bit on demand flexibility and the impact of distributed generation, energy efficiency, and VPPs as part of demand sensitivity. And then we also saw, some comments around, again, interconnection timing and electrification. But so all of these comments are part of what sort of formed the scenarios as we are going to sort of propose them today, trying to take this feedback into consideration. So the last section that I'm going to walk through here is our proposed approach to scenario design before I hand it off to Nate, who's going to walk through our scenario proposal. So, we tend to think about scenario development as a funnel. We start with the brainstorming session, the brainstorm step. We consider this to be the stakeholder comments that were submitted in February as the brainstorming. Let's try to capture as many ideas as possible. Today, we are in the kind of refine step where we have taken that brainstorm step, refined them into a set of scenario proposals, and we're putting them forth to you all for your feedback to refine them. And then the last step of that kind of funnel is to select the scenarios. So these will be informed by the comments that you all submit. Agencies will select those final scenarios that get studied in the IRP and the mitigation plan. When we think about our goals for scenario development, we really think about three things. First, we want to capture a diverse set of distinct future outcomes. We want to be able to provide support for clear and easy to understand decisions by the state. And we want to incorporate factors that can be studied quantitatively using available analytic tools. And I really want to emphasize that first point here around capturing a diverse set of distinct future outcomes. None of us can know from where we sit today what the energy system is going to look like in 20 years. And so it's really important that we capture a diverse range of potential futures so that we can inform the state in terms of what decisions should they take today that help sort of shape which one of those futures we pursue. I would say a poor outcome of scenario design would be a lot of scenarios that are very similar. That does not provide as sort of useful of information to the state in terms of figuring out sort of next steps that we should take. So we really want to be capturing a wide range of plausible futures when we think about scenario design. Second here, we're generally thinking when we think about scenario design is combining different policy decisions and how those might, how different decisions there might shape the future. And then also thinking about external forces and different futures that could happen with things outside of the state's policy control. And so we try to combine different elements of policy decisions and different elements of external forces together to create distinct scenarios. We will also additionally be conducting sensitivities on scenarios. And here, sensitivities are a variation of a single parameter within a scenario to understand its impact on key metrics, right? So we're just changing one piece of one scenario to be able to isolate the impact of that one component. In our stakeholder questions at the end, one of the questions is around sensitivities that you might suggest. And we really want to emphasize here that sensitivities mean just varying one piece of one scenario so that we can isolate its impact. For those of you who were involved in the resource adequacy study or the renewable energy access plan last year, this kind of concept will be very familiar to you in terms of how E3 approaches scenario design. But we tend to try to think about different factors and drivers of scenarios that have high uncertainty and high impact, and to try to identify those drivers to, again, draw that diverse range of potential futures and try to isolate and consider the impact of each of those on the system. So, things that have low uncertainty would tend to be modeled the same across all scenarios, again, because they are low uncertainty. Something that is high uncertainty but low impact, tends to not be as important in a scenario driver because it's less likely to really move the needle. So when we think about this combination of policy decisions and external forces, we are trying to combine the highly uncertain and high impact scenarios or drivers together. So on the policy side, we're thinking about demand side programs, clean energy policies, and resource retirements as the kind of policy drivers here. And on the external forces side, we're thinking about load growth, including data centers, industrial growth, commercial growth, and residential growth. Of course, electrification falls a little bit in both policy and external forces. For the sake of the slide, we have grouped it under external forces, but generally, we understand that electrification is both a policy decision and impacted by kind of wider market forces. Under external forces, we're also considering resource costs, performance, and development timelines, as well as considering emerging technologies. Okay, so my last slide here before I hand it off to my colleague Nate is as a little reminder, thinking about the scenarios and cases that we modeled in the resource adequacy study. Now, these are not the exact same cases and scenarios that we are proposing in this study, but it does inform how we think about things, having seen those scenarios in the study last year. Last year, we studied 5 different cases, and we really varied those on 4 different resource adequacy drivers that we were considering. We were looking at whether or not new gas plants were allowed in Illinois. We were looking at whether or not CEJA deadlines were and retirement deadlines were adhered to, or whether or not there was an extension. We looked at net zero emissions and whether or not Illinois was exporting enough green electrons to offset state emissions, and then also looking at battery costs and how lower battery costs might impact the system. And so those scenarios inform how we're thinking about scenario design for the IRP. And with that, I will hand it to Nate to talk through that.
Thanks, Charlotte. Just a final mic check. Hopefully everyone can hear me well. And thanks again for joining. By way of quick introduction, my name is Nate or Nathan Miller. I'm a senior director here at E3, and as Charlotte is our project manager for this assignment, I'm our project lead. And so I'm working closely, with all of you and with the agencies to undertake this work this year. So I'd like to build on the content that we have been discussing so far and talk about the proposed scenarios, just very specifics that we anticipate, getting your feedback on for this workshop and then using in the modeling process. Charlotte, let's go to the next slide, and first I'll talk about the load scenarios. So, as Charlotte already mentioned, we are required by statute to analyze 3 load scenarios. I also think that analyzing a range of load scenarios is critically important, given the environment that Illinois and both MISO and PJM regional markets are in right now. So, what we're proposing to do is to define these 3 scenarios in terms of a low case for load forecasts, a base case for load forecasts, and a high case. Each of these scenarios will have different load forecast components that comprise the total forecast, starting off with the baseline retail customers, as we've characterized them, and then data centers, electrification, and the loads outside of Illinois in the broader RTO regions of MISO and PJM. For baseline retail customers, this would be kind of all customer classes, residential, commercial, and existing industrial loads that exist on the grid today, in Illinois and in the wider regions. And specifically for these customers, we propose to use the same sort of fundamental forecast of retail customer load across each of these scenarios, low, base, and high, for this model exercise. The reason for that is because while there are, definitely a range of potential load growth outcomes from these customers that could be considered, back to Charlotte's original point, that we want to focus on high impact, high uncertainty factors. A change, all else equal, in these customer load forecasts based on population, energy consumption from kind of your macroeconomic regression-based drivers for a lot of these load forecasts. We don't see those as the largest driver materially of the load forecast. And really, it's data centers and electrification loads that are going to have a much more significant impact on the load forecast and also are much more uncertain. And so that's what we want to focus on for these 3 load scenarios so that we capture a reasonable range of potential outcomes from these significant drivers. Data centers, we're going to consider in a base case. Well, I'll start left to right across the board here. So we are going to have some data center loads included in the low case. And this is meant to be more of a bookend case, that only data centers that are in sort of active development and have a very high likelihood of coming online in the very near term will be included in this case. So this is meant to reflect a case where the utilities having line of sight to certain large loads in Illinois that do come on will be included, but then we're not going to assume any exogenous or additional growth rate thereafter. The base case is going to assume a continuation, some kind of a growth rate for data center loads, and that will be informed largely by Illinois utility forecasts, as well as other data that we can point to and anchor around. The high case, similarly, for Illinois only data centers, not data centers in the broader RTO regions, will have a higher growth rate that is designed to capture an upper bound bookend of data center loads that could reasonably be expected to be developed within Illinois in the service territories or really in the transmission zones of the regional markets that we're modeling, namely MISO Zone 4 in Southern Illinois and the ComEd zone for PJM around Chicago. For electrification, we propose to use kind of two different trajectories of electrification comprising EVs and building electrification loads. The low and the base case are going to have electrification projections, so really adoption of building electrification like heat pumps and electric vehicles that are informed by and anchored to historical adoption rates. And so that's meant to capture an expectation of as without additional major changes in what customers are choosing to do under current policies and conditions and economics of the cost of these end devices, this is what we expect to occur. Whereas the high load case, in addition to high data centers, will also include a higher electrification trajectory that is more aligned with the state's longer term multi-sector decarbonization goals. And that electrification load will be informed by work here from a pathway study, which is work for the Illinois Commerce Commission, um, analyzing various electrification futures. So we're going to take one higher electrification growth scenario. Now, why are we combining this with also a high data center case? This goes back to the scenario framing that we've discussed. We want to take a realistic bookend of potential load growth to inform the kind of maximum range that Illinois could expect over the forecast horizon and contrast that with the low range to understand what kinds of resource decisions are, common across those cases. The base case is designed to be our expected outcome, with the low and the high case being testing different boundary conditions for load. And then finally, what I want to note here is our proposal is to have across these three Illinois load forecast scenarios, the load forecasts for the RTO regional markets in MISO and PJM outside of Illinois to be consistent and the same across scenarios. Now, I fully reflect and recognize that the load forecasts across these regions are also highly uncertain and impactful. And this is also where we are trying to focus what is most important for Illinois. And I'll add just a bit more framing, and then we'll go to the next slide here, which is that building upon the work in the RA study, what we find is that a baseline expectation of load growth across each RTOs, we expect both RTOs to be tight on capacity and reliability over the forecast horizon from a number of factors, including aging coal plants, which will eventually retire, and the levels of load growth that we see across the footprints. And what that means is that it's less while what happens in the RTOs is impactful for Illinois, um, what is important is that across all scenarios here, we are reflecting a condition where the RTO markets continually need new resource builds to maintain their reliability standards. And that will be common across cases. And we wanted to then really double down in this analysis and focus on what's happening in Illinois against that common backdrop. So let's go to the next slide and talk about the clean energy policy targets. So I know most of you, if not all of you, are quite familiar with the policies in state, so I won't voice over too much in detail here, but I want to note that of the major in-state policies, the way we think about the goals that we will focus the model effort around, we really have two principal goals here. There is a clean energy standard, a target of 100% of retail sales, in 2050 as a state goal, but we really want to focus on the RPS trajectory and requirements in state for achievement of renewable portfolio standards, going from 25% in 2025 to 50% by 2040. And then, of course, the emissions of in-state fossil fuel generators under CEJA. And that's the other principal goal that we intend to reflect in our base policy scenario. I want to spend the rest of the couple minutes here on this slide talking about the chart on the right, because what this chart is designed to do is to illustrate what is embedded in current state policy between the RPS and the CEJA emissions limits and fossil fuel generator phase outs. In 2025, Illinois has about 50% of its power needs that are met by in-state nuclear generation. All right. And that is expect those generators, if they are remaining online through 2045, then we can expect the same amount of generation. But of course, as load grows, that 50% today will be less than 50% in the future, right? Similarly, then, but different, the RPS in 2025, which the state has met, of 25% of demand coming from renewable resources, both behind the meter and front of meter, needs to grow to 50% by 2040 and then remain thereafter. So there is a double growth, one could say. As load grows, the same percentage target also has to grow in terms of megawatt hours delivered, but then you also need to reach a higher and higher share of your growing load with renewables. So that is a kind of a major growth of clean energy resources that is required to meet this trajectory. But then I think what I want to cover for just a moment here is the what is left in state policy. And the way that the current policy works is that, the in-state fossil generators, so coal and oil and gas-fired power plants, have to retire between today and 2045. And as that in-state generation retires, there's going to be some additional amount of generation that Illinois needs. That is the difference between the new load that's added, the RPS resources that are added for policy, and the existing nuclear plants. And that's this top right gray bar, right? And a lot of our scenarios are actually focused on where, like, how is that bar being met? Basically, what kinds of resources for energy and what kinds of resources for reliability. And that's really going to be a lot of the focus of the modeling exercise here. Today, it's a mix of in-state generation and imports. Now, the current law allows for imports to continue to fill all of that bar in the future, or it could be met by additional renewable resources, but it's not required to be. And so that's where we're going to be focusing a lot of our scenario definitions. So let's go to the next slide then and talk about how we plan to model Illinois policy in a couple different cases. So these would be different scenarios for policies over time. So the table here is defined according to, two columns. On the left-hand side is our core policy cases. This is the interpretation of current policy enshrined in law today. And then we have alternative decarbonization paths, which are scenarios that we plan to test to inform all of you as stakeholders, as well as the agencies and policymakers in the state, as to how decarbonization could be met in a different path from what is enshrined in policy today. So first, I'll start with RPS policy. Today, there are defined ratios of what share of the RPS goals per year need to come from behind the meter solar photovoltaic systems, utility scale solar, and wind. And the Illinois Power Agency has a long-term plan that we are also supporting as E3. And what we've done in the RA study already is we used those same ratios, continued over time, aligned with the long-term plan, and that was a requirement that our resource portfolios had to meet in the base scenarios. And we propose to keep that for our core policy case. An alternative case that we propose to model is if we allow the model to adjust the ratios between behind the meter solar, and wind in accordance with the economics of those resources over time. So then I want to talk about the clean energy standard goal, that 2050 goal, and then Illinois in-state generation. So first, the clean energy standard. There is, as I mentioned, of course, a 2050 clean energy goal. We are not going to be modeling 2050 in this IRP cycle. Our model horizon is going to go from 2027 to 2047, inclusive of that 20-year period. And we will be on a trajectory towards that end state, but it's also a state goal that is not entirely defined. And we are going to stop the modeling at 2047 for this cycle and consider that in a future IRP cycle to model that end state. Now, as an alternative, however, we are proposing to run a scenario that assumes that that goal is a requirement in terms of a net zero requirement for the electric power sector. What do I mean by that? That is a requirement that 100% on an annual basis of Illinois load is met by generation from carbon-free sources. Now, that is going to be married to an alternative path for in-state generation as well, where in-state new gas generation and gas generation outside of Illinois or for imports into Illinois are both allowed through 2045, but they are also still constrained by this umbrella of net zero. And what that means is that in-state generation would be treated the same way that imports are treated, in the sense that both need to be offset by exports of equivalent zero carbon energy on an annual basis with this policy definition. Now, in the core policy case, we also, of course, will reflect the retirement schedule according to the CEJA emissions limits by different power plant types over time. And we will not allow GHG emitting generation in Illinois after January 1st, 2045. But we will, under current policy, continue to allow the model to choose, if it wants, imported generation from outside of Illinois for reliability and economics that may be GHG emitting and does not require that generation to be offset by exports. So let's go on to the next slide, and we'll spend a few minutes wrapping up before we get to the Q&A here. So those are the policy scenarios that we propose to test, again, to inform the needs and costs and requirements of meeting those different objectives over time, and also to identify commonalities across scenarios. We also, in addition, propose to test certain technology factors. And then the final slide here, I'll talk through how we've combined those scenarios to create a set of envelope conditions that we think as representative and informative for this effort. So here we're talking about two major technology drivers, demand side resources and emerging technologies. And we've categorized the assumptions for those drivers into two different categories, the core policy case and what we're calling system evolution futures. So for core policy demand side resources, we are going to be assuming a certain amount of baseline energy efficiency across all load scenarios. That is embedded, energy efficiency in current programs and policies and load forecasts. In other words, not a change from current policy, but the continuation of current policies and programs. Similarly, we are going to include existing demand response resources as part of the reliability mix, and there are existing demand response resources today, both within Illinois and outside of Illinois in the MISO and PJM capacity markets. We included those resources in our RA study, and we propose to continue to include those resources in our core policy case. We will also assume some kind of an exogenous, i.e., not selected by the model, but determined as an input to the model, virtual power plant resources, a quantity of those resources with certain performance characteristics that we're going to assume are built, uh, that are supported by and catalyzed by the post-Surge VPP tariffs that are being filed this summer. Now, as an alternative path in our system evolution, we also propose to test a higher energy efficiency trajectory to see the impact on the modeling requirements and other resources that are chosen, as well as allowing for an exogenous trajectory for a representative load flexible resource. So, what this means specifically is we're going to have to define the performance characteristics of a representative flexible load resource that has, a combination of shed demand response. In other words, load is dropping or reduced by a certain amount, a certain number of hours sequentially, and a certain number of times per year, and shift, where that load that is dropped during certain hours has to be made up for in our other hours, earlier hours, typically for things like smart thermostats. And the reason we want to have a representative shape for this flexible load resource that, again, will not be selected by the model, it will be um, defined externally as an input to the model of a growth of a certain amount of flexible load over time with these performance characteristics is we don't actually know. We'll talk about this more in our workshop on Friday as well, exactly what resources will be included in different virtual power plants. They can, a virtual power plant can include a number of different resources. And we will not be attempting to define every possible combination of virtual power plants, nor is that really necessary for a useful modeling result from this exercise for planning. What is important is to understand what a reasonable performance characteristic of these kinds of resources are. In other words, from the grid's perspective, how much load is reduced because of these resources over what kind of hours, how often, and how consecutive in sort of duration, multi-hours back to back. And does that energy need to be made up for in other hours? Yes or no, and how? So that's what we're going to be focusing on. And we'll be asking all of you for your thoughts and data and input around that input. So for emerging technologies, we propose for all core policy cases to include new nuclear reactors and uprates, as well as long duration energy storage at current market projections for timeline and cost. We'll talk a lot more about this as well as the demand side resources in Friday's workshop. So I want to kind of keep today's discussion as much as possible focused on the conceptual scenario design because we'll have a lot more time at the end of the week and in feedback from you all following that workshop to talk about the specific definitions of these resources. In the system evolution futures, we are proposing to essentially have a more optimistic trajectory of when new nuclear reactors and long duration storage are available for build and what kind of a cost we expect them to have given the large cost uncertainty with these resources. So with that, and looking at our time here, I want to spend the last few minutes talking about how all these scenarios come, or how all these different scenario drivers come together in our proposed scenarios. And then we'll hand off to Rochelle to take your questions, and we'll have the rest of our time here for discussion. So I'm just going to give a voiceover here that we have three different categories of scenarios in columns across the top, left to right. The first column, the far left, has three cases under what we're calling core policy planning futures. These are cases that reflect current policies of the state. We essentially propose to test how current state policies for RPS and fossil fuel phase out of in-state generators um, what kind of resources are needed to meet the state's goals and reliability needs over the horizon with the three different load cases that we have. So we'll have a base case with a base load forecast, a low load, and a high load forecast. Then we propose to test another group of three scenarios called system evolution. And this is designed to test how the resource mix for Illinois may change according to either the availability of more flexible loads in the high flex load future or a earlier availability of advanced technologies defined here as nuclear and long duration storage. The nuclear and long duration storage case we propose to test against the high load case. And then we also propose to test the high demand side resource trajectory against a high load case. And then we also are going to propose to test that demand side resources against the base case. So these three scenarios, compared to our core planning scenarios, they all have the same state policy objectives. What we're trying to tease out here and show and test is how the resource mix of what is built over time for Illinois may change with the load being lower or higher and with lower or higher availability of either demand side flexible load resources or these new technologies. And then finally, and then I'll pass it over to Rochelle for the Q&A portion here, we have a set of scenarios called alternative decarbonization paths. Now, these scenarios are intended to test the, um, in contrast to the system evolution, which is a technology future, these are policy futures, differences in state policies, which may lead to differences in portfolios. So the first case here is the CEJA extension case. This is what we are testing as part of the mitigation plan. What are the costs and benefits of delaying the shutdown dates of in-state fossil fuel generators, just with the base case load forecast? How does that change compared to the base case core policy future? We also propose to then test a net zero case, as I described, where we are going to allow for both imported power, as the core policy case does, as well as in-state gas generation from existing facilities and even new facilities if the model selects them for cost, as long as the generation from imports and in-state facilities are offset by equivalent on an annual basis clean energy resource exports from Illinois. We are then proposing to test that same policy construct of achieving net zero with a high load scenario, as an addition to the base load scenario. And then finally, we have one last case to propose here, which is an Illinois resource prioritization case, which is the same as the net zero base load case, but also allows the model to choose different ratios of renewable resources to meet the renewable resource targets over time. In other words, the model is able to diverge from the fixed ratios of behind the meter solar, front of meter solar, and front of meter wind over time. So with that, I will hand it over to Rochelle, and she will be coordinating and leading our stakeholder feedback and Q&A. Of course, you'll still have Charlotte and myself and the agencies represented to have to take your questions and take the next half hour here.
Thanks, Nate. Awesome. Run into, so as I stated before, we will have a stakeholder feedback comment form that you can find the QR code in the bottom right, as well as a link to this form is in the program materials. We are asking that we receive that feedback by April 21st. So you have about 2 weeks from today's date to submit your feedback, comments, concerns, questions. You can also send those there as well. But then you can also, if you have any direct questions related to IRP, you can send those directly to Joy. Her email is on the screen. And then in order for those questions to be routed correctly or to make sure that we are discussing the accurate information, just make sure that you have in the subject line IRP stakeholder comments workshop 1. But this QR code and the link will not be available until after this session if you're attempting to log in there now, but they will be made available at the end of the session. And then we'll run through quickly the questions that will be on that comment form. So the first one is, do the proposed scenarios reflect a reasonable range of the most impactful and most uncertain drivers? If not, which drivers do you or assumptions that should be added, removed, or modified? We'll also ask if there are any additional scenarios that should be considered, and then also any data sources or different inputs that you believe would be used to inform some of those key scenario parameters. And then the next question is, do these load scenarios capture a reasonable range of the most impactful drivers? If not, what specific drivers of load are missing. And lastly, we'll go through, for this study, sensitivities are defined as changes to a single input or assumption within a given scenario. And then we just ask for you to provide 1 to 3 sensitivities that you believe are particularly valuable to test, and then also including which input should be varied, and then what scenario this sensitivity should be applied to. Those will all be included. You don't have to memorize that, but those will all be included in that stakeholder comment form. Perfect. Awesome. And then now we'll run into the Q&A part of the discussion. So if you have a question or comment about a particular slide, we just ask that you make note of that slide or just notate it when you are giving your feedback. We ask that you use the raise hand feature to ask a question live. You can also provide feedback, comments, questions through there as well. When we see your hand raised, we'll go ahead and call on you. We ask that you unmute. And then before you start your question, we just ask for your name and organization you're calling from. And then you can go ahead and ask your question. And then you can also use the chat feature as well. And then we'll answer questions from there. So we'll start with live questions if we have any. Oh, I see Jason Smullen.
Yeah. Hey, everyone, and both the agencies and E3. Thank you, guys. I'm Jason Smolin. I'm with Roland Berger and also working with Emory, Illinois. 2 questions, but the first most important. Have the state agencies and E3 considered a more holistic set of policy outcomes for the scenarios? Really think we capture current law and relax decarbonization policy well. I think there's some clean heat standards, new rebates, credits, and other policies that don't seemingly show up. And I think that they could be valuable for more holistic strategic decision making, especially looking outward. So would love to kind of hear if you guys have had the chance to think about that and, if it's something that you're willing to think through moving forward.
Yeah, it's a great question. I'm happy to have an initial answer, and obviously, Jim from IPA, if you want to chime in as well from your perspective, if the ICC wants to chime in, please do. I would say one is that actually our net zero scenario, I can understand how some folks might view that as a relaxed decarbonization standard, but actually it's a more stringent decarbonization standard than current law, because current law doesn't allow or doesn't force that last gray bar of generation to be net zero, net of anything. So I just want to, maybe correct the framing there that we're not thinking about that just as a regression or walk back of current policies. We're thinking of it as an alternative way to actually meet a more stringent net standard than is actually in current policy, just as some framing there. Now, additionally, the uh, what you're talking about in terms of additional programs for namely, I'd say multi-sector decarbonization, um, which would be, clean heat or the electrification policies. That is where, for this cycle, I would say that there is an additional future of gas and kind of pathway study ongoing right now, which is going to have its own analysis and conclusions and report coming out. And I would frame that as, this IRP is the first IRP we're doing. We have quite a compressed time frame for this IRP, and so we really can't consider everything. And we also would ideally want to build off of that additional work that is being done under that study in the future IRPs. So I would say that those factors are definitely important to consider, but we would rather build on them in a future cycle than try to do something, quicker and accelerated in a very compressed time frame to have them be in this cycle. So we're trying to sort of treat them with care, I suppose, while recognizing the constraints of the timeline that we are working under for this cycle.
Yeah, I appreciate the care and thoughtfulness there. I think would be intrigued to talk offline about whether net zero and exports and imports fit additionality, and whether that is truly more aggressive decarbonization policy. But I'll leave it there. I know other folks have their hands raised.
Yeah, I saw some hands go up on that. Understood. That's totally fine. That's why we're talking. We are exploring different decarbonization pathways. And again, we do a lot of this modeling at E3. We've supported a lot of other states in this deep decarbonization analysis. And as long as wind and solar generation or nuclear generation is delivered to the grid, i.e., not curtailed, it is displacing another resource on the grid. And if there is not curtailment happening, at a system level or regional, zonal level, we can get more into it. It means you are displacing carbon from another marginal generator.
Perfect. Thanks, Nate. Thanks, Jason. All right, next one that I saw hands up, Matthew. Go ahead.
Yeah, thank you. This is Matt Tomk from Ameren, and appreciate the presentation today. Not being somebody that is really well versed in integrated resource planning, just going to ask more basic questions here. One of the questions I have, I think that is on a lot of people's mind with respect to scenario development is load forecasting. How granular do we anticipate getting with respect to large loads? And a couple sub questions there. Are we looking at any particular models with respect to large load forecasting that may be preferable to others? If so, what are they? And then two, we know that there's, given the size of these, we can predict with at least some precision the timing that these large loads come in, even down to the year or a couple years. How deep do we want to go on that in this analysis? Or are you considering maybe something more of a growth rate type of from estimation for these large loads?
Yeah, Matt, that's a great question. I think I could take the next 25 minutes talking about that. At E3, we support a lot of utilities. We are working actively in MISO and PJM specifically. We're also, pretty plugged in to data center loads and drivers as well as anyone in the industry. I would encourage folks to maybe look at our study for the state of Virginia, the JLARC study, which is a public study out there looking at large load impacts on rates in Virginia and what the different trajectories of large loads might be as a state that's also grappling with this. I'll answer your question directly. So the level of granularity for the plan, the integrated resource plan for Illinois, is going to really be at a transmission zone level, right? So we're not looking at, this load sited exactly at this substation, interconnection that is below the level of granularity for really any IRP. And so what's most important are a couple factors. Number one, how much of this large load is going to be added at what year in the different Illinois transmission zones, namely the ComEd zone and the Southern Illinois Ameren MISO Zone 4, right? And then additionally, what kind of a load profile do those loads have? And so we will be modeling those loads with a separate and distinct, 8760 hourly load shape to them that will be scaled up by the name, sort of the peak megawatts of that load that is added over time. So then the question becomes, well, where are we drawing the data for that? Because that is your next question, right? And this is where we are going to be, not to be cheeky, we're going to be drawing some of that from Ameren and ComEd and their own forecasts based on requests the utilities have received, because, that's not so much of a model that can predict where data centers are going to be sited, though, there may be some ways to guess at that. We want to understand where the actual requests have come in and what volume of them. And I've seen some other, chats here. We don't want to be assuming that everything gets built exactly as is. We know there is a lot of double counting and sort of inflated expectations of, you don't know if the hyperscalers are having, say 10 load interconnections across 8 states, and they're really only going to build one of those facilities, right? And we don't have good data on, attrition rates for that. This is all so new and so rapidly evolving. So what are we going to do? What we're going to do in brief here, and then we'll have to go on to some other questions, but this is an important topic, I think, for the frame out, is we are going to be relying upon more of a growth rate trajectory, but it's going to be informed by the differences between some data we've gathered on, call it attrition of loads. Like once loads connect, they only use 70% of the peak power they requested, or things like that. And we have some information data points that can be sort of best informed. We also, can look at sort of a bottoms up approach of like, hey, we have some data that says these 4 data centers are being built here, and this is their load trajectory, and this is what's being built in other places. And we can draw a growth rate from that, and then sort of have a higher versus a lower growth rate from that. So the idea is like we know that in the time and space of this engagement and how new all of this is and how persistent or durable these large loads will be is still uncertain, but they're definitely real. And so we definitely want to reflect that reality, but we want to reflect it in a reasonable envelope. And that's why we have kind of this high load case versus a base case. I think it is probably about as bearish as possible to assume that only a couple data centers get built and then nothing more happens. So I would say our load case is characterized in my mind as a pretty unlikely but important bookend. And I would say that we're trying to design that base case load growth to be a kind of best guess expectations.
Okay, thank you. Appreciate that response.
Yeah.
Perfect. Thanks, Matt. All right, next on the list, Madeline from NRDC.
Hi, good morning, everyone. Thank you. Madeline Smithson with NRDC. Just two general questions for E2 and then one for staff. First up, is interconnection reform or barriers being removed considered in this modeling process, or is that solely going to be considered in the REAP docket? And then for the EE baseline levels, I think on the fifth scenario, does that take into account just CEJA or the new provisions in SURJA? And then I just have one more question for ICC staff after that.
Great. Yeah. No, thanks for those questions. Um, okay, we'll just take them one at a time. So let's take the energy efficiency question. So energy efficiency baseline scenario. Energy efficiency, obviously, as we can all appreciate, has many different components. New windows are energy efficiency, insulation in homes, as is, a new air conditioner with a different standard of how much power it uses to deliver the same customer benefit, right? So it is a whole, like, kind of big, challenging catch-all category to model. We are not going to be modeling, every individual component at granular level. Energy efficiency is typically baked into load forecasts from utilities as a change in the growth rate. If not for existing energy efficiency, growth would be X, and with it is now forecasted to be Y. And that is of the baseline load shape of all kind of customer classes. So that's broadly how we intend to capture kind of current energy efficiency. We are definitely going to be considering whether and how precisely the energy efficiency callouts and goals and provisions in SURJA may translate to, megawatt hour savings and what quantity that should be. That is something that is on our docket to develop for that baseline scenario. But the idea is that the baseline scenario should encompass kind of basically current policy energy efficiency and not kind of incremental changes or step changes beyond that. Interconnection. Let's talk about interconnection for a brief bit. The short version is that interconnection processes, we are not going to assume any material change in those processes, especially kind of an improvement in those. But I also want to be clear that that is an important factor in getting resources online. Both RTOs are actively working on that. It's also something that we are still reflecting in the model. So it's not something that we're ignoring, even if we're not treating it explicitly. So I'll say one more thing here. Basically, what we're going to be doing, and we'll actually come back to this a little bit on Friday when we talk about the resource candidate parameters. It's going to influence the earliest online date for resources, especially in the near term, right? And then it's going to influence our view of what we kind of allow the model to choose when. So in the very near term, next year or the year after, we are going to be adding resources to the model that are not quite so much interconnection process constrained, but we only want to build that the model doesn't get to choose what gets built tomorrow, because what gets built tomorrow is already under construction. And if it's not under construction, it's not being built tomorrow, right? So we have kind of a near-term nose of the forecast. We'll talk about this a lot more on Friday. That is going to be constrained and informed by the interconnection queue and the stage of project development and what projects those are. And then there's going to be a handoff period around 2030, 2031, where we let the model actually start making selections by resources, but the amount of megawatts and the megawatts per year the model is allowed to choose will be informed by a view of interconnection timelines. So hopefully that addresses the question, at least in part.
Yes, thank you. And then my last quick question is, can the ICC staff share more about what the docketed proceeding will look like in November? Is it going to be similar to the REAP as a investigation docket, or will it be something slightly different? Thank you.
Hi, Madeline. This is Jim Zelnarek from ICC staff. Yeah, I don't think we've quite nailed that down yet. I mean, obviously the legislation calls for an investigation, but I don't think we've scoped out exactly what that will look like in terms of, process at this point.
Thanks, Jim.
Perfect. Thanks, Madeline. Next one on the list, Sean Brady, Brady LLC.
I'm having a hard time getting off video. There we go. Hi, I've got a question about slide 10, the IRP inputs. You've got an asterisk here around transmission constraints, say that they're new or expanded data set. What does that mean on the transmission constraints? New or expanded data set?
Sure. I can comment on this. So part of this comes actually from the Renewable Energy Access Plan, where we are doing a more detailed study with the utilities around constraints across Illinois. And so those inputs are informing how we are modeling transmission constraints in the Integrated Resource Plan.
Okay. When will that, isn't that already available?
We are in the Renewable Energy Access Plan study. We are currently working on that. There was a workshop last week. Would encourage folks to check out the materials from that because SERJA also requires that the Renewable Energy Access Plan solicit transmission solutions. And so we will be posting the sort of high-level constraints that we are seeing across the system in that and asking for stakeholder solutions to that.
Okay, so that's kind of the input set that you're talking about here.
Mm-hmm. Yep.
And then when will you be reviewing? Earlier it was mentioned like the candidate resources, that'll be reviewed on Friday. Which of these inputs will you be reviewing further? For instance, I'd like to make a comment about the inflation rate at some point. And so I want to better understand what what your parameters are going to be before I start making comments. So when will some of this information, when will like the meat be put on these data inputs?
Yeah, that's a great question. I'll take that at a high level. Obviously our team is up and running on all cylinders,
Yeah.
speak. So we are actively working on all of these inputs, like right now. And so I'd say, in our general workflow timeline, we expect the next month to be a very intense month on input development. And so I don't have a specific date to be able to explain today, but I would say that's something that we'll want to circle back with the agencies and then get back to you all about. So it's a great question. I apologize that I don't have a date certain answer right now. This is a very live effort, but we are also,
Yeah.
really working on it.
One suggestion I might have then is, not all this information is going to be of interest to everybody. So maybe ask people now to flag, hey, are there certain data inputs from this slide that a stakeholder would be interested in you covering in a later meeting or in some fashion. That way you don't have to dedicate a whole block of time to something that people may not necessarily be interested. So kind of get a reading from people early on. So that's one suggestion I have. I'll get back in the queue for other questions I have. Thanks.
Thanks.
Thanks, Sean. Next, we have Jason from Form Energy.
Hey, Nathan. I had a question and a comment for you about slide 27. And I was curious what the rationale is for only allowing RPS resource flexibility in one sensitivity. And in particular, it seems important to allow RPS resource flexibility in the system evolution features, especially with the sensitivity with the low cost of advanced nuclear and long duration storage, because there are oftentimes interactions between these resources and the portfolio mix. So curious about your thinking on that.
Yeah, that's a great question. I think that's also the kind of thing where, feel free to submit that kind of in written feedback from the collection here. The general thinking is that we, the RPS resource flexibility, well, I'll answer this in two parts. Just bear with me. So number one, the way in which we are going to model the policy achievement for RPS is we are going to set a constraint for the capacity expansion model that the model needs to meet these targeted, basically megawatt hours per year from different designated resources, behind the meter solar, front of meter solar, front of meter wind, over time, right? And so the model is going to be allowed to build more renewables than the constraint, than the target, if they're economic in the total optimization decision. So I just want to be clear with everyone that this is not a ceiling, this is a floor for that kind of build, based upon, the model's decision making. So with that in mind, we're not constraining the model. Like the constraints on wind and solar will be more about how much you can build in specific areas before you run out of resource or land or something like that. So the RPS resource flexibility is allowing the model to just choose a different mix between solar and wind and behind the meter solar. And the reason why that's not across more scenarios currently, at least conceptual framing, is that is a pretty fixed policy of the state today. And so we wanted to reflect, state policy consistency across more scenarios rather than fewer. So that was the rationale generally around that. We thought it was important to include to test that somewhere, but we didn't want to. We wanted to have a lot of scenarios that still reflected current policy.
Thank you. All right, we'll go to Seth Kaplan, Grid Strategies.
Yeah, thank you. Just briefly building on Madeline and this question and Kevin's, just in terms of following up about transmission solutions and acknowledging looks like you really are starting the materials from the REAP study that you're digging into there. Just wanted to ask about whether the whether the base that you're working from will reflect actual data from the utilities on generation projects that have withdrawn due to high upgrade costs and identified constraints in the system, and in terms of what could potentially be addressed through either new technologies or upgrades. Um, as that's one key, whether that would be in the base. And similarly, whether looking forward, there's going to be any consideration of, general asset condition upgrades to be able to ensure that the system can continue to can handle, upgrading the current infrastructure in addition to new stuff that would be needed. And then finally, relatedly, um, whether when you look at um, if you could just clarify what the model would show in terms of imports and exports, what could be done in terms of increased transfer capacity to be able to bring in and out renewable energy in and out of Illinois. Uh, what will be modeled going forward in terms of drawing in and then potentially being able to help meet regional needs from Illinois resources.
Yeah, great question. So transmission is going to factor in a number of places in this study. This study is not going to be, I mean, it's an integrated resource plan and the mitigation plan. So it's about generation resource adequacy, right? And it's about a portfolio mix at a transmission zone level. That's the granularity of the study. So we're not going to be identifying in this particular study, individual substation constraints or anything that's below the level of a zone, a transmission zone outside of the REAP zones, right? Because we are using the same underlying Plexus model that we are using for REAP. right? So that's the level of granularity of transmission representation. Okay. Regarding transmission imports into Illinois, we are proposing to continue with the approach that we used in the resource adequacy study to essentially reflect today's transmission import limits during on-peak periods as defined by the RTOs, in their capacity market modeling, like the CEDL limits into Illinois zones. And that is a typically a D rate from the maximum flow, and that's been done based on RTO analysis. So that's how we're going to reflect those import limits. Now, I also want to reflect, because this was some comments we got on the RA study, where I think we can clarify more further the approach, even though it was written up in the document. We are not assuming that there is generation available from the RTOs over that transmission line. That's why, in order for the transmission to support Illinois' planning reserve margin and reliability constraint for optimization, we are going to require that there are new build resources selected by the model that have properties of a new gas combustion turbine outside of Illinois. Okay. So in other words, we are reflecting kind of today's import limits and the proposed expansion of those limits for designated upgrade projects that are already in planning phases. But we are not just assuming there's generation on the other end to count towards Illinois' RA requirements.
Okay. Well, I mean, yeah, I mean, it makes sense to not count on anybody building something that you don't have control over. But so, and I assume that varying the import limits might be one thing that might be studied.
Yeah, varying. So that's something that we'll probably want to circle back on. Very this is we are wanting to represent transmission at the right level of granularity and data within the time that we have for this modeling effort. And we have a lot to do within this modeling effort. And we also have transmission information and representation coming from the REAP study that will inform that basically constraints and upgrade costs. But I also want to be clear that this is not a detailed transmission study. It's not the purpose of this study. So we want to reflect the materiality of those constraints in the generation decisions of the model and the portfolio optimization in a fair and specific data informed manner. But this is not a detailed transmission study.
All right.
Thank you.
Yeah, understood. Yeah, it's a real limitation, but yeah, okay.
Perfect.
Yeah,
Thanks,
so
Matt.
we're going to be reflecting real world limitations at the right level of granularity is what we're aiming to do here.
Thanks, Nate. All right, we'll move on to Andy from ComEd.
Yes, thanks. Am I coming through okay?
Yeah, can hear
You
you.
are.
All right. Thanks for hosting this, and also thank you for getting the materials out ahead of time. It was really helpful to review. There's a lot. One question I was wondering about, it's possible you all thought about it just more as a sensitivity, but I was curious about how you think about like broader federal policy, particularly around really like decarbonization and clean resources. I assume you'll maybe take current policy as status quo, but did you think at all about whether that belongs in a scenario to toggle that, or were you thinking more on the sensitivity front?
Yeah, great question. Obviously, federal policy is uncertain. I'll just maybe put a giant period there and an underscore, and we can all agree without going off on many minutes there. With that in mind, we are going to represent current policy. In other words, the expiration of tax credits for wind and solar, the PTC and the ITC. We are going to reflect the current July 2025 reconciliation bill foreign entity of concern requirements. They are going to be embedded in our resource cost expectations, and they will also be informing, like battery storage will have access to a tax credit along with nuclear under current policy with a assumption of a safe harbor 4-year period. So we have all of those detailed assumptions around that federal policy. Now, obviously, there are other federal policies as well outside of just tax credits that I think belong in the context space, but not maybe an explicit the model space. I mean, I won't, again, there's too much to say. We can just name things like offshore wind as one big question mark there. And that is something that does have an effect on the industry, on real resources, on Illinois because it affects RTO balances. So I don't want to downplay those, but I also this, going back to we have to have a reasonable container to assess in this compressed time frame. So we are going to, as best we can, represent current policies and not assume a change materially in kind of resource cost or federal support, kind of in either direction from current policies, either regressive or progressive from a perspective of decarbonization. Now, with that in mind, the last thing I'll say there is I think that that may be, important to consider, in the longer arc. This is just the first IRP in a very compressed timeline, and we are in the environment that we are in terms of macro and political conditions right now. So it's not that they don't have a place, it's that we are trying to take kind of high impact, high uncertainty factors again as the biggest pieces to evaluate. Also with the eye towards this IRP is going to both inform in a dotted line sense longer term decisions as well as inform very more concrete near term decisions. And that's what we're trying to focus the model effort around.
Understood. Thanks.
Yeah.
Thanks, Andy. All right, next is Sean Anders from CWLP.
Good afternoon. Thank you for all this information. It's been very helpful. My question was, how are you modeling the capacity factors and the availability for intermittent resources, or rather, how do those align with, say, RTO modeling factors for those, especially given like the new MISO seasonal construct? And if they don't align, why not? What was the decision there? And kind of as an extension, how are you treating VPPs in a capacity and energy sense, given that they may or may not have the same performance requirements or
That's a great
commitment
question.
requirements?
Yeah, there's a lot there. I think that's probably best addressed on Friday and post our presentation on Friday because we'll be talking in much more detail about how we plan to represent candidate resources. And I know we're kind of coming up at time here, so if you
Sure.
don't mind, I think I'd rather punt that till Friday after we kind of lay out the approach there and handle that in follow-up Q&A.
All right. I appreciate that.
Yeah, it's a good set of questions. I'm happy to treat that, just maybe not right this moment.
Perfect. Awesome. All right, next we have Sean Brady again from Brady LLC.
Hey, I've got a question on slide 23 regarding the data centers. So for the high case, are you saying that you're not looking at the potential data center load that we've got growing forecasted, both in the MISO states on our west as well as in the ComEd states to our east? I think we've got about 6.3 gigawatts in neighboring states, and we've got about 23 gigawatts of potential load of data centers forecasted. So are you not accounting for those in this model?
Great question. So for one, I would there's a lot more documentation on the approach and representation of loads and resources in the RTOs outside of Illinois from the resource adequacy study. So I would encourage you for additional detail to look at the technical appendix as well as the main body of the report for the RA study because we are using the same capacity expansion model topology and framework for this. We're building off of that for this.
Okay.
So that representation of how we have defined the reliability constraints across the RTOs outside of Illinois versus within Illinois will be reflected here for this IRP and mitigation plan. specifically on data center loads. So what that means is we are reflecting the loads and resource balance outside of Illinois in the model framework. What we are saying here is that we are not going to consider what we're proposing is not considering a range of low, medium, high data center growth outside of Illinois, as well as within Illinois for Illinois' own planning purpose. Because one, we want to focus on Illinois. Two, we recognize that the more growth there is outside of RTOs, the harder that, button is to button, the higher the bar to maintain reliability. And we see that being, challenged in both PJM and MISO, but really in PJM acutely today. So it's not that it's not important, it's that a range of hard, harder, hardest all mean the same thing for Illinois, which is that there aren't resources outside of Illinois' borders that, without new build, can meet Illinois' reliability standard, right?
Right.
So that's what we're kind of anchoring to. And so that goes back to the scenario framing of high impact and high uncertainty. I would say that there's a lot less uncertainty that the RTOs are going to be strained for capacity for the foreseeable future, given these dynamics. And happy to expound on that more. And that we are wanting to focus on sort of Illinois' specific load resource requirements as the focus of this effort. So there will be, in short, data center load forecasts outside of Illinois that also are part of resource retirements and builds outside of Illinois that the model is considering and seeing that are related to the decisions the model will make for Illinois' load and resources.
Okay. Thanks. I appreciate that because I should have opened up and said I really appreciate your approach on slides 19 and 20 where you talked about high risk and high uncertainty and accounting for those and having some look at that. I think what will be needed around that is some sort of getting some feedback from stakeholders on the risks around that and how that kind of translates into kind of a sensitivity situation. My concern in the long term is you're modeling something that a lot of states had complained about regarding Illinois and such that Illinois was so tied to the PJM and MISO market signals for growth and not with independent with utility IRPs, that their other states' concerns was that at some point we'd be feeding off of other states. And so this IRP is intended to correct that to a certain extent by having a forecast to make sure that we're growing generation in Illinois to meet our load in Illinois. However, in the longer term, with the growth of the extreme and rapid growth of data centers, this modeling downplays Seth Kaplan's concern, which was the need for transmission so that the entire each RTO can move generation, move energy to compensate for shortfalls in other regions. And so I think that's going to be kind of an indirect impact that will need to be compensated for in the REAP, I think. So I'll just share that with you at this point, and probably we'll need further discussion on that in comments. But that's a high-level concern that I have is how this modeling and just downplays the need for transmission that we're going to need. That's going to help provide stability across our grids, both PJM and MISO. Thanks.
Yeah, well, I appreciate the comment there, Sean. I do want to push back respectfully a little bit on that we're not downplaying the transmission need. It's about what we are trying to serve as the objective of the study and what's material for the needs of Illinois, okay? We are not in charge of, nor should we be in this study, trying to solve for AP Ohio's local transmission needs to integrate data centers, right? Now, the total resource adequacy balance from a generation over a range of loss of load conditions is very material for Illinois in this study. And we are reflecting that in this study with a pretty high degree of quantitative modeling. Okay, we're doing loss of load modeling. We're doing forecasted ELCCs by resources within each RTO's specific framework, and we are going to be reflecting those values under the capacity market constructs with a fundamental evolution trajectory in all scenarios for Illinois. So we are being, quite basically we are putting our analytical efforts and power where the focus of the study is, right? But I'm not able to, in this compressed timeline, solve for localized transmission issues across the entire footprints of half the country, right? So I just want to push back
Right.
a little bit on that we're not downplaying the importance of transmission. It's about where the right amount of effort and the right representation of those issues is from the perspective of Illinois' specific reliability needs, exposure, concerns, and in-state resource mix.
And I agree. I mean, the IRP this isn't a transmission expansion planning exercise. So
Nor is it a
that
regional
is,
exercise. It's an Illinois
it's,
exercise.
pardon?
It's an Illinois focused exercise. It's not
Right.
solving PJM's problems. It's not solving MISO's problems. It's trying to understand what is Illinois' share in this complicated dynamic, taking into account these macro conditions, right?
Right. I guess what I was saying is the scope of an IRP doesn't extend to changing transmission lines. That's a transmission expansion plan. So I do agree that you're staying within the scope of what was defined in statute. I'm just pointing out as a policy matter that's outside that's for commissioners and legislators, limits
It's
of
very
the information.
important. Yeah, it's a very important concern. Don't get me wrong. It's critical, and like we are quite aware of that context. I also want to give some
Yeah.
comfort here. We can come back to Seth here. We are like to the extent that these interconnection rates you know are not going to allow resources to get built fast enough to solve for the top line PJM load growth, that is likely going to mean in reality that that load growth cannot be accommodated, or that the RTOs will just maintain a short position over the forecast horizon for quite a long time, right? And local deliverability issues also are part of that equation. So I'm not saying that it's not in the study. It is actually very part and parcel of the greater context of expectations of how much load we're putting into that RTO forecast and how the model is able to solve for that external to Illinois load resource balance over time, right? Basically, I mean, from Illinois' perspective, narrowly, right? What matters is if the RTO has excess generation available for Illinois or not. And I would say that many more signs than not point to shortfall across the
Right.
regional markets, right? So by
Agreed.
reflecting a condition, whether it's again harder, or hardest shortfall, it's going to result in the same kind of macro condition input to Illinois for the sake of Illinois' exposure and planning, right? And so like that is what we are actually going to be very explicitly treating and accounting for in the study. So again, it's a very
Agreed.
important issue.
Right. Yeah.
I don't want to downplay that at
Thanks.
all. We're just trying to capture it sort of in the framework in its appropriate place.
Right. Agreed.
Yeah.
Thanks.
Perfect. Thanks, Sean. Next hand up, Neil from American.
Yeah, hi. Neil Hammer, Mid-American Energy. Nathan, I guess my question is kind of it feeds off of the last discussion, but it's you mentioned data centers external to the Illinois area, and it sounds like you have a reasonable approach for how you're doing that. But my question is around, you mentioned you're going to look at a different hourly profile for data centers within the state. Are you doing that for the external system? Because it seems like those hours of need, those really high important hours, they'll be MISO wide and PJM wide, and data centers have a lot higher load factor. So I'm wondering if you're going to have a separate hourly profile for data center growth outside of Illinois too. Thank you.
Yeah, great question. The resounding answer is yes, we will. And also, yes, we did in the RA study. So that was already reflected in the RA study findings. We used a separate data center load profile in the derivation and forecasting of hourly loads inside Illinois and outside of Illinois, and we will repeat that approach here.
Thank you. We have one last hand up, and then we'll do some chat questions as well. So Seth from Grid Strategies.
Yeah, and just very quickly, just to follow up. I mean, and I know that we are well on or past the boundary of what is currently in scope, but just in terms of a very real world concern that I think will be of great interest to a lot of folks. Just noting what happened during the last winter when a lot of renewable energy projects in Illinois were kind of locked in and prices went negative and were unable to export. And I just think in terms of a plan that is trying to real world foster the resources to meet the state's goals, that phenomena is a very, very significant one. And I know it's a really tough one to model. And I know that it doesn't fit within the conventional framework. And I know that it is getting into federal jurisdictional transmission lines and that are not within the scope of this, but it's a very real phenomena in terms of that if you have a situation where when there is a need across, in this case, PJM, and the projects in Illinois are unable to serve that need, and it has a profound effect on their economics, which it sends a pretty potent signal that it ain't a good place to build projects in and would undermine meeting the policy needs. So I know that's a really tough one, and it just doesn't fit well into the modeling paradigms, but it's just a very real phenomena that is worthy of mention and discussion. It's somewhere in the REAP and to some extent in the IRP.
Yeah, I appreciate the thoughtful response there, Seth. And yes, it is a real world challenge. We are very keenly aware of it in the work that we do and in our kind of technical, modeling chops. There's a lot more we can say about this, so maybe we can have a bit more discussion on Friday with our resources. I, to your point about a bad place to build, a lot of that comes down to contracting term, risk assignment, things like that, which is also kind of downstream of an IRP process, as I think we can all understand and appreciate. So, these kinds of transmission flow issues, uh, our objective here with this study, right, is to treat them with care and materiality in the kind of core modeling objectives of what the IRP is trying to solve for, along with the REAP and its objectives and the mitigation plan and its objectives. So I think this will be a continued conversation with you all over the coming months and after the plan is even draft results and then filed and everything. So look forward to that. It's a real world concern, as you said. So I just want to add validity to that. I agree. And also we're going to represent the impact of those specific conditions as best we can for the sake of the objective of the study and Illinois' decision making for this cycle.
I hear you on the contracting side, but I mean, perhaps I'm overly affected by having worked in project development in renewable, including in Illinois. I'm just saying, if you're unable to export out of Illinois, you're not going to get the CNI contracts that a lot of folks are depending upon. And given the fact that you are including in the economics a merchant component beyond the life of a IPA contract and such, that it's not solvable through pure contracting mechanisms. That reality is reality, and if it's bottled in, it's bottled in, and that just has an effect that can't be dealt with through contracting mechanisms.
Yeah, I think there's probably a lot more we could say on that topic as we go forward here, but point appreciated.
Great. Thanks, Seth. All right, we had a couple questions in the chat. Scott and Mallory, I don't know if you want to ask your questions live. If not, we can state them in this chat if you'd like.
If you could just read it, that would be appreciated. Thank you.
Of course, yeah, definitely. So the first one was off of slide 23. In integrating high loads forecasted from Illinois utilities and the RTO, please perform some data checking and cleansing to avoid double counting the same large loads and the potential to create an unreasonable high load scenario. It's a comment.
Yeah,
Perfect.
no, appreciated. We are certainly aware of the very real factor that If you take the sum of every utility's load forecast based on requests to interconnect that you receive, you are likely going to include some double counting. The data is it is what it is, so we have to work with what we've got, and it is certainly our intention and objective to avoid double counting in our load forecasts.
And then
I
you
would
had
say just
one.
broadly, sorry, Rochelle, turn right back to you.
No, go ahead. Sorry, I was just going to read his second question. Go right ahead.
Yeah. We'll get to that in a moment. I just want to say more broadly, and picking up on some of the points we were just discussing, right? There is a broader question of, hey, even if you had sort of perfect insight, which no one does around, double counting loads, right? Because it's impossible to know. You can't go inside of the hyperscalers and just like know what they're doing, and maybe they don't even know what they're doing exactly in all of this. Even if you had perfect foresight there, I would say that there is still a macro problem where the amount of load additions nominally may still exceed the grid's capacity on a reliability needs perspective, right? And so you're still kind of left with this macro condition of, can you really build enough resources in the next 2 years to avoid being just short on reliability? Yes, no. And then how much of those facilities are going to, have some amount of self-gen or load flexibility or something? There's a lot of nested kind of uncertainties there that need to be considered thoughtfully, as we are going to endeavor to do in setting that data center load forecast across the cases.
And then
Thank you. So perhaps you'll address any potential for double counting in really the contracting phase after the IRP.
We're going to try to address the double counting issue in how we define the inputs and in how we consider what the IRP model results are saying. We are also going to be considering the specific forecasts of data center loads within Illinois, from the utilities themselves, the service territory utilities, ComEd and Ameren and Mid-American, and then, looking at the RTO is just collecting those load forecasts largely from constituent load serving entities, right? So we're going to try to do the crosswalk as best we can there.
Thank you.
Great. And then Scott's second question, if PJM's reliability backstop procurement ends up dictating some specific resource purchases for Illinois, will you create a disruptor scenario to account for these added resources and reductions in otherwise planned resources?
Yeah, it's a great question. I think that's one of many factors that we're going to have to consider in where and how those are reflected. For example, other relevant but somewhat different scenarios are the RRI queue of resources in PJM and the ERAS queue in MISO. We put those resources in as exogenous build resources on time. And those resources were assumed in the RA study. So we're kind of adopt a similar perspective there. Regarding the backstop procurement, we also want to make sure that, if it's going to be incremental additionality, that we're counting them, but we're not double counting them. Like if the backstop procurement is a contracting mechanism for resources already in the RRI queue, that would be double counting to add them back in, right? So I just want to note that like we're aware of it. We're going to take it into account. It's a thoughtful question. And it kind of goes into what the baseline expectation of non-model choices are, right?
Thanks, Nate. Next question, just cognizant of time, we have about 10 minutes, but we'll just run through the last few questions that we've received. So Elizabeth Wheeler from the Clean Grid Alliance, general process question on slide 11. Will updated scenario drivers and resource availability based on this round of feedback be shared prior to when results are shared or modeled, or shared and modeling is conducted?
Sure. I think we want to take that back and talk with the agencies so that we set forward that plan. And so I think we will come back and revisit that question.
Perfect. Thanks, Charlotte. All right. Next question from Hillary on the last slide. Do any of your CEJA case models inform grid readiness, hosting capacity improvements, and distributed generation access by economic region across Illinois, therefore informing the types and locations of renewable energy project development that should occur and the complementary workforce and contractor capacity needed to support those regional opportunities?
Yeah, Charlotte, do you want to
Sure.
talk just from the REAP perspective?
Yeah, so I think a lot of what you're asking here, Hillary, is really best addressed in the REAP process. So as part of the Renewable Energy Access Plan, the REAP, we're looking at 7 different renewable energy zones across Illinois and what necessary upgrades we would need in those areas to help facilitate renewable development and renewable deliverability to the state in line with state goals. And so that process is much more focused on that kind of subzonal view of the transmission system. And so, I think in terms of I'm thinking we sometimes call it headroom or deliverability of how much can you get renewable energy out from where it is being produced. And so I think that is probably best addressed through that process where we're considering it. And then I think to your question on workforce development, that is kind of outside the scope of the REAP. But I would say, given that there are distinct zones in the state, there are 7 zones, that you could probably do some crosswalking between where the zones that are being studied are and what the workforce needs might be there.
Thanks, Charlotte. All right, last question that we have in the chat before I pass it back to Jim for a closeout, from Emily Sims from ACEEE. In modeling the impact of high load flexibility and energy efficiency, how will demand side resources be considered as resources to meet the gap between forecasted load and generation highlighted in slide 24?
I feel like that's a perfect segue to Friday to say that
I think it is. Yes.
Yeah.
So we'll probably handle that one in more depth on Friday when we talk about how we reflect different candidate resources.
Awesome. Thanks, Nate. Thanks, Charlotte. Any other questions that we have in the last few minutes? Sean, go ahead.
Yeah, thanks. This was a question I had back from slide 7, and maybe on slide 7 it says that you will evaluate trade-offs between cost, reliability, and environmental outcomes. Is that just kind of a high-level description of the overall IRP, or how are you doing those? What criteria are you using for doing the trade-offs?
Yeah, that's a great question. I mean, that's ultimately kind of the big picture question that the agencies and us and supporting them have to wrestle with, along with all of you, stakeholders. So there is no formula enshrined in law as to, the value of each of those things that you can just kind of plug in and say, well, here is the answer, right? It's a complex series of judgment calls. The short version is we plan to calculate each of these things and produce those results across scenarios to inform what those trade-offs look like in different futures, and for them to be then weighed and considered by decision makers in Illinois.
Okay, great. Thanks. Nice job.
Thanks, Sean. All right, I think we are all caught up with questions. I will pass it back to Jim.
Thanks, Rochelle. Appreciate it. All caught up with questions until we're not. More, I'm sure, will come through as we have the questions set out. So as a quick reiteration of where we started, please see here, there's the workshop 1 stakeholder question set. You can also pull it down directly off the comment feed if you look at the posted materials for today's session. As I had mentioned at the start, this is being recorded. This workshop is being recorded. It'll be posted probably in about a day, sometime I'm thinking tomorrow, once everything is rendered. The other note is many of you, hopefully all of you, had seen this morning a communication went out, an announcement about Friday's session. The materials have been posted for that session as well now, so you can go out and see what's ready for that session, prepare for it accordingly. It's very similar in the concept, but obviously different topic than we had today. And I know a number of questions were pushed there. So hopefully you'll be able to find some, maybe all of your answers there, and prepare for additional questions and comments that you have at that session. The Friday's call itself is another 2-hour workshop, same time slot, just different day. That one will also be recorded and materials will be posted. So with that, the last items we have is just reiterating where you can find everything and should go going forward. The IPA's website, now called the RA Hub, Resource Adequacy Hub, actually has a series of different sets and information that you can go through to. Both the workshop materials for the RA mitigation plan, links for the IRP process, as well as the workshop information. In the IRP section, you'll see a link to the ICC site and vice versa, the ICC hosting the materials for the IRP process as well. So you will see some duplication. That's on purpose. So if you go from one spot, you can find all the same stuff. We don't have different things, different places, at least at this point. So again, appreciate everyone's time and attention throughout all of this, all of the questions, great conversation, and we will see hopefully all of you on Friday. With that, the workshop is completed.
Thanks, everyone.